And now, boys and girls, ladies and gentlemen, and brothers and sisters, it's time for a little fireside chat. Madhumita Ventakataramanan of WiredUK will be talking to Danielle Fong, and her issue is why the climate problem is really urgent and what we need to do to tackle it. So, welcome on stage to Madhumita and Danielle. Make some noise for them!
Hello, and I would like to invite on stage Danielle Fong of Lightsail Energies. Hello again. Do you want to sit down? So, Danielle is the co-founder and chief scientist of Lightsail Energy, which is an energy storage startup, which many of you would already know. She's also a mentor for the thiel 20 under 20 fellowships, and she's an advisor to several hard tech startups, as she calls them, which includes biotech, cleantech, and physical technologies. I'll let her tell you a bit more about her journey, but just to start you off, she entered Dalhousie University when she was 12 years old and graduated in physics and computer science at 17. So, Danielle, do you want to start by telling us a bit about your journey to Lightsail, how you got there?
Yes. Okay, so this is on. This is great. So many articles often start with the fact that I started college at a young age. But before that, and probably more important, was the fact that I left junior high school because it was just too slow. It wasn't getting me to where I needed to go. And actually that, dropping out of something that isn't going to work, is something that I kept coming back to. So I threw this slide up because that's more or less how junior high school felt. So when I realized that the doors weren't locked, I went and tried to find another way. And there was a very good university where I grew up, so I could stay at home and then take the bus and learn about physics and computer science. And it was really a great thing. Initially, it was a little overwhelming as a kid, but as time went on, I felt my inventive powers growing. And essentially, I decided to do the most important thing that I thought I could. And at that time, and I think even more strongly today, that was trying to solve the climate challenge before us. So I think that was really what's driving me. What was the most important thing I could personally do? I think there are a lot of great challenges we face as a society, but in terms of challenges where there's a missing technology and that's blocking, that's something I thought we really had to work on. And so that's why I focused on energy. Yeah, so this is maybe jumping forward a bit, but that's more or less, that brings me up to the next part, which is like why it's so critical, why it's so urgent.
Yeah, so you've talked a lot about like the urgency of this problem. So tell us what kind of, in your opinion, what's so urgent, what's the problem that we're facing with climate today? Okay,
so I've tried to tell a story that simplifies things a bit, but it gets across the essential truths, the essential science. And the issue is that there isn't really a threshold for climate change. Things just sort of get worse and worse and worse. And there are certainly positive feedback loops and times when a species finally goes extinct or an ecosystem declines and then falls. But what I've tried to get across is the magnitude of the problem and how quickly we're coming up upon it. So there is international agreement today as to the temperature rise which we must strive to stay below, because if we don't, we have huge problems. And basically there's international agreement that was reached. It's non-binding, but something called the Copenhagen Accord agrees internationally that we are to stay below a 2-degree temperature rise, 2 degrees Celsius rise.
So we can't go beyond 2 degrees temperature.
That's the target. Right?
Okay.
And that is presumed to avoid most of the worst consequences, although there will be some. Yeah, so that's basically what that means. But what that means in total is, you have a number of challenges. There's some sea level rise. That means that Amsterdam gets flooded a lot, but you have to build like lots of dikes. They're pretty good at that. New York stays relatively dry.
Okay.
You have a lot of heat waves in Europe, but you don't have desertification. So sort of the next threshold would be desertification all throughout southern Europe. You have coral reefs that are bleached in many places, but they're not actually dead. So many of those ecosystems are alive enough so that they could thrive in the future. You have problems with corn and wheat yields, food, but not too much of a problem, not too much that it would cause mass starvation most likely. You have increased power of storms, but maybe we can deal with it. These sort of things are manageable. If it gets much beyond this, you have much more irreversible consequences. And the problem is that there are two things you really need to understand about climate change that really define the mathematics. And one is that carbon dioxide stays in the atmosphere for a very, very long time, thousands of years. It's like a blanket you can't take off, and you're just getting hotter and hotter. But the second thing is that power plants last for a very long time. So whatever you build, as long as you keep using them and keep using coal. Base or natural gas or oil, which apparently we do. I mean, that's the evidence. We actually do this. Then it will last for about 50, 60 years. So one thing you can do is, because carbon dioxide stays in the atmosphere for a very long time, you can create essentially a budget, the total amount of carbon dioxide you can send up into the atmosphere over time. And what you get is about 860 gigatons. Well, as of last year, it's ticking down. That's the budget. And you find that we have more than enough fossil fuels to exceed that entire budget currently on the books, registered, accounted for in the first stripe, the yellow there, that's publicly traded companies. The next is other reserves you could build, and then there are state-owned reserves. You have more than enough carbon fuels, so that's not the limiting factor. It's really whether or not we decide to burn it. We have the equipment to burn it. In fact, at today's level of burning, we'll be out of that budget in 17 years with just minor increases, the sort of historical increases over time. And even if the Western world takes that to zero, you have the fact that power plants last so long. This is a graph that shows the age of US power plants. And you can see here, over up there, that there are many operational power plants in the United States, at least, that are more than 50 years old. And they're making them even longer lived through improved technology. Mm-hmm. So when you combine that with the massive increases in power plants being built, particularly in China, you get some really ferocious numbers. So this is, the black is the actual Chinese coal growth. The teal is the projected coal growth. And actually, there have been many projections throughout time, and you find actually that the actual coal growth has exceeded most of the projections throughout time. So you can just do a bit of math, and you find if you use the coal plants that are being built, that are slated to be built, until 2030, and you use it throughout a 50-year lifespan of how long that coal plant can burn coal, that's 3/4 of the carbon budget just by itself. So, we wait a few years and then go to zero, and then Chinese coal usage, and no automobiles continue unabated, we're through the budget. So even though it's not a threshold, that should give you a sense of just how far off we are from the targets. I mean, we are not close at all. Yeah, so basically the challenge is, as the population centers of the world that aren't currently using a lot of power, they're not currently filled with modern technology, as they light up, where is that power going to come from? And
right.
that was the problem that I chose to devote myself to.
Right, so the problem is that the world as we know it is going to change over the next 17 years, whether we like it or not, and we have to find an alternative, basically, to power ourselves.
There is a relentless drive towards modernization. It cannot be stopped.
Okay.
People are going to want clean ovens, refrigeration, air conditioning. They're going to want to be able to move around in their own vehicles. They want lights, cell phones, TVs, laptops. So if we don't supply power in a sustainable way, a radically more sustainable way, then we will also have severe climate change.
So what's the solution? I'm sure it's not that easy and that obvious, but from where you're sitting, what's kind of a way that we can tackle this problem and the way that you'll use?
So as a 17-year-old, I thought I had maybe an answer to this, and I would join up to a giant project in nuclear fusion. This is global collaboration to work on the energy that powers all of the stars. And I still think that this is likely to be the answer to having truly abundant energy forever. And it's almost, if it worked, it would be almost magical. You could travel anywhere that you wanted in 45 minutes. You could have as much energy as you need. We could colonize the stars. But we weren't there yet, and unfortunately, it wasn't quite. It wasn't something I could personally influence, and it wasn't moving fast enough, especially to track with those. The time frame that I put forth before. So this is a cutaway diagram of the mega project that's being constructed in the south of France. It's an international collaboration called ITER, which in Latin means the way. But this was almost the only thing that was getting funded in the area. I pointed out the graduate student for scale there. It's more or less how I felt. And the problem is that the time frame is, at the moment, the optimistic time frame has commercialization in 2050. Basically, the war will be completely lost by that point, if you buy the previous argument. So first I was depressed, and then I left. I dropped out, just like junior high school. Not quite like junior high school, but fairly close. And I went to the Bay Area. I mean, the idea, so at the time, I was like, OK, well, the right research isn't getting funded. What can I do? And ITER, though it was a mega project, it was $14 billion at the time. And Facebook was valued at $15 billion. And so I was like, those don't seem like of equal difficulty, actually. And even though the cost of ITER has increased, it's inflated to almost $50 billion over time, Facebook has appreciated in value faster than that. So the plan was to travel to Silicon Valley, create my own fortune, and invest in the right energy research. I didn't have a network, so I wrote a lot on my blog, and I reached out to a bunch of people. Actually, one of the people I talked to, it turned out, was Justin Kahn. Who
we were just talking to about that.
It was unbelievable. Like, a small group of friends, people who knew each other 7 years ago, through Hacker News and Y Combinator. I never was part of Y Combinator, but like the venture firm, we didn't get funding from them, but I was part of the community, and they helped me out. And eventually I came upon an idea. So through this whole period of time, I was trying to make some startup to make some money to then do energy work. But ultimately, the energy problem pulled me more. Throughout this entire period of time, renewable power was reducing in cost. Actually, so basically, this is solar panel module prices. They were declining exponentially. And they had actually gone down below the cost of conventional fuel in many places in the world. And that's increasingly so. It's not everywhere, but it's increasing in areas. It started out with the islands and places you had to use diesel fuel, and then it's expanded throughout. Renewable power, cheaper than conventional power. That was a really big shift. It basically happened just as I entered graduate school. This is a graph of oil prices. After oil went up, above about $40 a barrel, renewable energy was cheaper. So that's still true for about 50 gigawatts across the world. And increasingly, as renewables come down in cost, that keeps going. But the problem is, and we mentioned this when I was studying fusion, they said, you can't store economically, solar or wind, so therefore we have to do nuclear fusion. It's the only way. And I just said, well, you know, the technical problem of storage may not be equal to that of fusion. It may be much simpler to solve the storage problem. But the problem, and lots of people knew about this, is that batteries were a very large, well, they were very expensive. Which was one problem. Maybe you could bring it down to close to the cost of the materials. They still might be a little too expensive, but then the other problem is quite severe. They degrade rapidly. They degrade when you cycle them. They degrade just sitting on the shelf. I mean, if you think of chemically what you're doing, you are dissolving and then reacting some material and then replating it, hoping that it goes into more or less the same shape as it previously was. And there's some pictures here, electron micrographs of lithium metal after you dissolve it and then replate it. It grows all these hairs. There's a lot of internal resistance. This reduces efficiency and reduces capacity, and that's what happens. So actually, Bill Gates points this out. All the batteries on Earth store only 10, if you add them together, they store only 10 minutes of the world's electricity. So we're not close to what we need there. And I asked the question, what if we stored energy in air? So
before we get into what Lightsail does, are there some other energy storage solutions out there other than batteries that kind of exist but don't work for some reason?
There are a couple. So the largest one, the one most in use, is something called pumped hydro. Okay. So if you just think of a hydroelectric dam, you have water at a higher place. You let it run down a turbine, and that generates power when it goes into a lower place. Well, what if you can pump it back up to that higher place? That stores energy. So that's about 2% of the world's power is covered with pumped hydro, and there's a lot in Norway because of the fjords. There's a lot in Switzerland. That buffers France, which has more constant power from its nuclear power plants. So yeah, so there are some others. The second largest, actually, in practice, actually is a form of compressed air energy storage, but it has an essential inefficiency, which I'll get to in a bit, that we tried to overcome.
Okay. So let's get to Lightsail. So what was your big idea?
Well, sort of the thesis of the company, the reason it was so enticing was that air obviously is very inexpensive, and air compressors and tanks are very inexpensive and they last for a very long time. So this is very different from the battery problem where you have something that doesn't last a long time, it's hard to make it last a long time, and it's pretty expensive. The problem is different. The efficiency had been lower with compressed air technology. So I asked, why was it inefficient and could that be overcome? And the problem, this is the only equation in the talk, I think. The problem is when you compress air, it gets hotter, and hotter air reaches a higher pressure than it otherwise would. So you have to do more work to compress it. Then when it cools down, you lose temperature and you lose pressure. Therefore, you lose energy that you could get out of it. And what you want is for the air to be as cold during compression as possible and as warm as possible on expansion. So we came up with this idea. What if you cool it by spraying water into the air compressor? You put the air in a tank, you store the heat, and you actually can use the heat if you want. If it's near a building, for example, it can provide heating. And then you spray warm water back during expansion, which can be further warmed with solar heat or waste heat. And that solves the inefficiency problem. It about doubles the efficiency.
So basically, you're taking that heat, which would otherwise be lost, and storing it in water.
Exactly, yeah. It's a simple concept. And strangely, I found nobody had really done it. So that was the key. And when we realized this, when we realized nobody else had done it, we couldn't find any essential problems that couldn't be overcome with some engineering, we realized we had something. And also, it's reversible. So you can do, with the same system, both a compressor, it can both be a compressor and an expander. Yeah, so anyway.
Cool. So where are you today? So you've got the technology, you've kind of proved that you can scale it. So where is Lightsail now? How close are you to kind of deploying it out there on the grid?
So I'll quickly run up to the present day. So it started out where we were 3 co-founders. Some of the smartest people that I knew came together. And Steve actually came up with an idea for an extremely inexpensive air tank. He's in the middle. Ed on the right. He's such a consummate engineer that he had like a machine shop in his garage, and he built this thing. So here it is. This is going to save the world. Actually, it's a yeah, that was a prototype. It was the very simplest thing we could build. It looks like it should be, at a state science fair or something, but we scaled up quickly. So this is an industrial gas compressor, which we modified to show it working at industrial scale and very efficiently, very quickly, doing compression and expansion with the water spray process. We proved that the technology worked at high efficiency, and we figured out what economic formula we had to solve in order to make energy storage truly economical with renewables. This is it. It's off-peak power plus energy storage. That cost needs to be less than peakers and grid storage.
So what efficiency have you come up to? Or I don't know how you
so our
measure it.
targets are 55% for the pilot and 60% for the product. We think we'll sort of asymptote out at 70% if we don't do anything with heat. If you use the heat, you can actually save energy in a building, or if you have waste heat, you can recover that and have more energy coming out in electricity than put in electricity because you're absorbing so much heat. So there's a bunch of things we can do. Today, we're a little below 50%, but we're making a bunch of really good progress.
And is that comparable to like pumped hydro, as you were saying?
Yeah, that's about 10 to 15% lower than pumped hydro.
Okay.
So we have to keep working on it.
You're aiming to get there.
Mm-hmm.
Okay.
Yeah, so we have, let me just show you, we figured, this is the thing that we think will do it. So this is the design, we built it. Actually, can we go to the video here? Yeah, so that was just a short clip in operation, but yeah, we can head back to the slide deck. So this is it on the left. So actually, despite the fact that we're not currently at our targets, we're already much more efficient than any air compressor or expander on the market. So actually, this can plug into any power plant and improve the efficiency. This can plug into any time you need compressed air, which is actually 4% of worldwide electricity usage goes into creating compressed air. So it's already a pretty useful thing. So that's on the left here. And then on the right is the world's least expensive air tanks. We've made them out of an advanced material that is both radically stronger than steel, and even though it's less expensive, or more expensive, it's less expensive per unit of strength. So we have almost $90 million in pre-orders of just the tanks.
Right, and that's going to be just for the compressed air across?
Well, it's a compressed air, and also we can sell it into other markets where people need to move natural gas, for example, which is, it's a nice side market as we launch the company.
Okay.
Yeah. So that's, and we're deploying next year, first in California, and then in the Caribbean, and also probably Hawaii, and definitely Canada, and possibly France. So.
Okay, wow.
Yeah.
So across the world.
Yes.
And do you see, so obviously renewables are still just a small percentage of the grid right now, but do you see that kind of exponentially increasing, especially in the developing world? And
well, the right way to look at it is it's not like spread around. It's not like everything is tweaking up by like a % or so. There are certain areas where it's going to almost all of the new built electricity. And an example of this, really amazingly, is in the Middle East. Most of the new power plants people are building, instead of taking oil out of the ground and burning it, which is incredibly wasteful economically as well as environmentally, they're building solar plants because there's very good solar. So in islands in the Middle East and places where you would otherwise use oil, the world is moving to renewables extremely quickly. And basically, it's capped right now because they don't have energy storage. And you cannot get any new power plant approvals if you don't include energy storage, them to a very large extent. So this is limiting it. And once we have this technology, you can go to 100% renewables in those areas, and it'll increase across the world as the cost comes down.
okay,
Yeah.
great. So moving a bit away from the science into the business side of things, what are kind of some lessons that you would give to other energy startups? What are the kind of challenges of being an energy startup versus a software or a regular tech startup?
Right. So So everything is harder except for the size of the market. It's a lot harder. Raising money is harder. The technology is much harder. The regulatory stuff is harder. And that means you have to get more right early on. You can't iterate like a lean startup idea. You have to iterate on your strategy, and you have to get very good intelligence and information and talk to customers and do things like this. And after you place your bets, and it may be several years before that strategy pays fruit, so you've got to get it right. And that usually means not following the crowd. There have been many competitors and many people in this sector that have believed things about why you would use energy storage, that if you believe them too strongly, and that alone, it will kill the company. So you have to constantly be doing reality checks. You have to think of things from first principles. You have to think for yourself. That said, even though it's difficult, it's necessary as a society for us to do this. And the business that does crack it will be on a path to creating literally trillions of dollars in value and saving the world, going down in history, perhaps.
That's great. And you've managed to raise quite a lot of money from that world that you
Right,
originally
yes.
went.
We've been able to beat the odds. And the way that we did that was we had to, instead of going to the specialist firms that said that they were going to do this, we were noticing they were exiting the field. And there hadn't been a new batch to take their place. So we had to go to investors who could invest in this and were basically aligned, and explain to them why we were a good company. And in many cases, we were their first energy investment. Although they were extraordinary investors like Peter Thiel. We weren't quite Bill Gates' first energy investment. We were like number 3, I think.
Okay.
Yeah.
Great. So what in the energy space do you think are kind of the biggest opportunities at the moment, and then the challenges as well?
Well, I think there are 2 ways to look at that. So the first is what are the market drivers, where to look and where to deploy, and the other are the technologies and the technology trends. So as far as the market is concerned, look at the places where power is currently very expensive. So everywhere where you don't have infrastructure already, so Africa, the Caribbean, Southeast Asia, to a large extent India, these places have very high cost of electricity. So that's a market driver. On the trend side, obviously there's energy storage, but there's also integrating systems so that you can have something much more efficient. So if you think about, we have air conditioners, heaters, refrigerators, and ovens, and they're all opposites. And each one is trying to move heat from one point to another. That could be an integrated device, and it could be cheaper and more energy efficient. And the final thing, and it's made a lot of news, is fusion.
We were talking earlier, Lockheed Martin just came up with its idea or design for a new reactor, didn't it?
Right, so I have to be careful what I say here. So first of all, I think it should get funded. And I think the reason that they announced it is that they're not funding it internally, because Lockheed, they deny that anything exists for 10 years until it's been flying missions for 10 years. Right. In general, more small projects like this should get funded. There was a lot of thinking very early on in the 50s and 60s for how you would build a nuclear reactor, a nuclear fusion reactor, and to a large extent, people have been following on those old strategies, and there are many more strategies that can go. And we have these amazing existence proofs. We can achieve fusion in the lab. We can achieve fusion in bombs, lots of it. And every star and our sun use fusion all the time. I really think that nature is not, has not teased us with the possibility, but restricted us from being able to harness it for peace. So I think it is possible. Whether or not that particular idea is going to get us there, I'm not sure. But the amount that we invest in stuff like that is ridiculous, and I do believe that it's possible. So.
Great. Yeah. And just as a final note to end on,
Sure.
What are you really excited about? Either companies or technologies that already exist, or kind of the next big research idea in energy? What keeps you getting up every day?
Well, I have to admit the fusion and the compact nuclear reactors are very exciting. There's also dramatic improvement, incremental improvement in the cost of wind, and there's a big advance if you can make concentrators less expensive, and there's a huge advance in wind if you can basically fly your wind turbine. So there's a company called Makani that flies around a wind turbine high up in the atmosphere, getting a lot more wind that way, that we're excited and we may be partnering with. So.
Great.
Yeah.
So I think we've run out of time. I see red flashing lights. So
Yes.
that's it from us. But thank you so much, Danielle.
Okay.
Thanks.
Thank you, everyone.